to our whiteboard and we compare a dynamo, a DC generator, sorry, with an AC generator, this is the main difference that will happen. All right, this is the main thing that will happen. The DC generator will produce a waveform that will only be on one side of the grid line of the graph. So it will only be on the positive side. It will not go to a peak negative. The DC generator only produces voltage on one side, whether positive or negative, but in most cases positive. So instead of having both waves, the wave on either side, the wave is on one side, which gives the current, when it gets to a peak, when the current gets to the peak is represented by a straight line. The peak is represented by a straight line. Therefore, DC is now known as direct current because it only flows in one direction. So this will now be DC direct current because it only flows in one direction and its peak is only on one side. And this over here now is alternating current because the current flows between positive and negative. Direct current will only peak on the positive side. Therefore, the current is only flowing in one direction. So it basically goes from 0 to peak positive, back to 0, back to peak positive, back to 0. And the same amount of cycles would be the same amount of cycles in your direct current. But because the wavelength is much less, the cycle is much more frequent with the direct current. So we don't refer to direct current in terms of cycles. We refer to alternating current in terms of cycles. Direct current is, all right, so let me put this in a practical sense. When you connect solar panels to your homes or to your businesses, the current produced by solar panels it is produced in direct current. It's produced in direct current because the solar panels convert the light energy into electrical energy, which is now stored into batteries. These batteries are storing energy in direct current. In order for it to use into your house, it has to pass through a process called inversion. And an inverter now has to take the direct current and change it into alternating current. And that alternating current now is applied to your breaker, and you can have that supply in your home. Simply put, if you are converting alternating current into direct current, you still need that inverter circuit to change the AC into DC. You do that every day. When you plug your phone into charge, your charger is plugged into an AC socket. The charger block, which is a transformer, breaks down the voltage into a smaller voltage. But that voltage it breaks it down into is an alternating voltage. The circuit inside of your phone, the power circuit inside of your phone, will now invert that alternating AC into DC for your phone to operate. All right, we have less than a